Okay, so now we're going to use the quadratic formula. We're also going to use the value of the discriminant to determine the type of roots a quadratic equation will have and solve using the quadratic formula. So here you go. First off, remember we have the general form ax squared plus bx plus c equals 0. A can't be 0 because if it was, that would just get rid of the x squared and then we'd have a linear equation. So to have a quadratic, A can't be 0. Now, you probably remember the song. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. Okay, so how do we solve with quadratic formula? Well, first step, get into standard form. Then we take those a's, b's, and c's and plug them into this formula. We crunch the numbers using the order of operations, and then simplify the radical and reduce the fraction to the lowest terms. So we're trying to take it as simple as we can. So we're going to do each of these with the quadratic formula. So first off, we want to identify, A, B, and C. So A is 3, B is 5, C is 1. And we know that because it's already set in standard form equal to 0. So I just set up my x equals the opposite of b plus or minus square root b squared minus 4 times a times c all over 2a. 3 there. And now you just crunch the numbers. X equals the opposite of 5 plus or minus 5 squared is 25 minus 4 times 3 times 1. So 25 minus 12 is 13 all over 6. And that's as far as you can go because 13 does not reduce. And that's our answer. Now this one, it's not in standard form yet, so we have to move that negative 9 over to make it x squared, said minus and wrote to our right of plus. Minus 6x plus 9 equals 0. Now I can identify A, B, and C. A is 1, B is negative 6, and C is 9. X is equal to the opposite of B. Now, that doesn't mean negative 6. It means the opposite of whatever B is. And since it was negative, it's going to become positive. Opposite B plus or minus the square root of B, careful, B squared minus 4 times A times C all over 2 times A. So, the opposite of negative 6 is positive 6, plus or minus the, 6 squared is 36, minus 36. Yes, I'm writing this one out just to show you what happens. Just be 2 on the bottom. Whoops. I'm just going to do that. Now, that means what we're going to get is 6 plus or minus.
If you're a
we're going to take the square root of 36 minus 36, but that's the square root of 0. So we actually end up with 6 plus or minus 0 over 2. Well, 6 plus 0 and 6 minus 0 is the same thing, so we end up with just x equals 3. And now, once again, we have to move this over. So we have 2x squared plus 4x plus 7 equals 0. Well, A is 2, B is 4, and C is 7. So to move down here to have some room, well, I guess I'll do it here. X equals the opposite of B plus or minus the square root of B squared minus 4 times A times C, all is 16 minus 2 times 4 is 8 times 7 is 56 over 4. Well, look what we're going to end up with. X equals negative 4 plus or minus the square root of a negative number. Negative 40 over 4. So there's still lots to do here. We need to simplify. Now, negative 40 is negative 1 times 4 times 10 over 4. X is equal to the opposite of b, negative 4, plus or minus. Now, the negative 1 is going to come out as an I. Square root of 4 is going to come out as a 2. And the 10 is going to stay inside. And then we have a 4. But we can reduce. So we can write this as x equals negative 4 over 4 plus or minus 2I over 4 times square root of 10. And now we can simplify. X equals negative 1 plus or minus I root 10 over 4. Or 1/4. I'm sorry. Not 4. Over 2. Or 1/2 I root 10. So notice what we have here. On the first one, we have negative 5 plus or minus radical 13 over 6. If we turn radical 13 over decimal, we would get 2 different answers. In this middle one, we only got one answer. And in this one, we have an imaginary answer. So, how are they different? We can use the value of the discriminant. And the discriminant is just this part. To help predict how many and what kind of zeros or roots the quadratic function has. So, let's look at the ones we just did. Okay? So, on the first one, we have radical 13. For the second one, we have square root of 0. And for the third one, whoops, wrong way. For the third one, we had the square root of 10. Well, actually, from the very get-go, negative 40. Before we simplify. Well, notice, for the first one, there were 2 solutions, plus or minus that number. For the second one, there was only one solution. And for the last one, there were none, because it was above or below the x-axis. So if the value of the discriminant is positive, a positive number, like we had there with 13, we end up with 2. If it's 0, it's 1, and if it's negative, it's none. So, find the value of the discriminant and describe the number of solutions. So first off, we have to move this bad boy over by subtraction. So we have 0 equals negatives. Well, we have to put it in order also. Equals negative 3x squared minus 7x. 2 minus 6 is minus 4. So my A is negative 3. My B is negative 7. And my C is negative 4. So I'm just going to do the b squared minus 4ac. Negative 7 squared minus 4 times A times C. So that's going to be 49. So negative 7 squared is 49. minus 4 times negative 3 times negative 4. Well, negative 3 times negative 4 is positive 12, times 4 is 48. So what we end up with is 49 minus 48, square root of 1. That means we're going to get two solutions because one is positive, and they are real roots. Okay, on this next one, we need to move the 1 over. 16x squared minus 8x plus 1 equals 0. So A is 16, B is negative 8, and C is 1. So B squared, negative 8 squared, minus 4 times 16 times 1. Well, negative 8 squared is 64. 4 times 16 is 64. So we end up with square root of 0. That means we're going to have one solution, and it's going to be real. You can pretty much guess what this next one's going to be. I'm going to move this over. 5x squared minus 2x plus 7 equals 0. A is 5, B is negative 2, and C is 7. B squared minus 4 times A times C. Well, negative 2 squared is 4. 4 times 5 is 20. 20 times 7 is 140. So that's going to be 4 minus 140, which is negative 136. That means there's going to be no solutions. They are imaginary. Non-real roots. Okay. Describe and find the error. So actually I'd like you to look at this and hit pause and see if you can find the error. And then come back and we'll go over it. Hopefully you're back. Hopefully you did hit pause. So on this one, A is 1, B is negative 3, and C is negative 2. So first off, this should be the opposite of negative 3. It is. There's your B, 4, A is 1, there's your C, and then there's your A. Let's see if they crunch the numbers right. 3 squared is 9. Negative minus 4 times 1 times negative 2. That should be 9 minus negative 8, which should be 9 plus 8. So here's the error right here. It should be x equals 3 plus or minus square root of 17 over 2. Let's look at Edwin's. A is 2, B is 4, and C is negative 7. This is not the opposite of B, so this should be negative all the way down. Let's see if there's any other errors. Here we have B squared, that's fine. Minus 4 times A times C, that's fine. Times 2A, that looks good. 4 squared is 16, that works. 4 times 2 is 8, times negative 7 is negative 56. You subtract that, it becomes plus 56. 56 plus 16 is 72, which breaks down to 36 and 2, which means 6 root 2. That's what they have right here. So that looks good too. And 2 times 2 is 4, so that looks good. So the main difference is not having that negative 4. So the only difference is this should be negative 1. Negative 4 over 4 is negative 1. And that's